Nixie tubes are gas discharge tubes used to display numbers or symbols in an illuminated form. These tubes typically contain noble gases such as neon. Each number or symbol is pre-shaped as a thin wire and placed inside the tube. When the correct voltage is applied, an illuminated image is obtained with the help of these wires. But first, let's hunt down the scientific foundations upon which this technology stands. Quantum mechanics has shown that if the right energy is given to an atom, that atom will ionize. Nixie tubes use this effect by applying a voltage difference to the gas between two wires inside the tube through these wires, thus giving energy. This energy ionizes the atom. The ionized gas provides electrons to the environment, and this electron can ionize other gases as well. In this regard, Nixie tubes fall into the cold cathode tube category, as they do not affect the environment through thermionic emission. At the same time, the ionized atom due to the voltage is attracted by the negatively charged metal through electrostatic force. If this atom collides with the metal, it takes an electron from the metal and becomes neutral again. Additionally, if the collision energy is sufficient, it can knock an electron from the metal and provide electrons to the environment. Quantum mechanics has shown us that if you excite an atom with the correct energy, this atom emits light as it returns to its ground state. Thus, depending on the gas filled inside the tube, the desired light is obtained. This is the principle of fluorescent lamps. However, Nixie tubes emit this light in specific shapes, so atoms are first ionized and then moved to the desired location by voltage. The atom brought to the desired point is then excited and made to emit light. This allows light to be emitted in the desired shape. Now let's hunt down the components that make up Nixie tubes. Nixie tubes are filled only with desired gases. These gases are helium, neon, and argon. Because they produce a nice light in the visible region, have relatively low excitation energies, and do not chemically react with each other. These gases must be more abundant than other gases in the environment. This is done first by vacuuming and then filling with gases. At the back of this environment, there is a black anode. The reason it is black is so that the light is more clearly visible. This metal is at a positive voltage, so it is bombarded by electrons and therefore must be made of a strong metal. This anode must not be only at the back because gas is everywhere. The anode extends to the front of the tube, but to see the radiation, the front anode must be perforated. This creates the distinctive appearance of the Nixie tube. The metal shaped into the desired form is kept at a negative voltage. This metal is the cathode. Since voltage must be applied to the desired cathode, the cathodes are separated from each other with small ceramic pieces. Because ionized atoms will hit this cathode and emit electrons, the metal must have a low work function but high resistance to wear. Therefore, this metal is usually preferred as tungsten. The anode and cathode metals are connected to metals protruding from the bottom of the Nixie tube. These metals are responsible for carrying the externally applied voltage into the tube. The Nixie tube simply consists of these components. Now that we know both the methods and the components, we can hunt down how it works. The moment we apply a negative voltage to the metal we want to light up in the Nixie tube and a positive voltage to the general anode metal, we can give enough energy to ionize the helium, neon, and argon gases inside the tube. As a result, the ionized gases accelerate towards the negatively charged metal. Acceleration means an increase in kinetic energy, so these ions can ionize other gas atoms by colliding with them. These ionized gases eventually hit the metal, and as a result of the collision energy, they both knock off a free electron from the metal and take an electron for themselves to return to the ground state. Gases that need to come to the metal to return to the ground state accumulate quickly around the metal. The electrons knocked from the metal start to gain kinetic energy under the positive voltage. However, before reaching the metal with positive voltage, they hit the gas surrounding the cathode and, if their energy overlaps with the quantized excitation energy, can transfer it. Therefore, for the electron to excite the gas, it needs to gain sufficient energy over a certain distance, so there is a dark region around the cathode metal. This region is called the Aston dark space. The electron that gains enough energy excites the gas around the cathode by colliding with it. As a result of this excitation, the gas quickly returning to the ground state emits visible light, and as long as this voltage is applied, it continues as a cycle. In this way, Nixie tubes emit light in the desired shape. Now we know everything about Nixie tubes. Our next step is to make our own Nixie tubes. Good luck hunting this down. Remember, quantum mechanics has opened such a door for us that it is a mysterious structure that makes everything that seems impossible possible, as we can see from Nixie tubes. Thank you for hunting. Don't forget to subscribe and leave a comment. Stay with science.